let's move on to the next presentation. Mariana, you're terrific with these emoji. So Team Monsoon Blues, mentored by Risa Madoff, members Steffi Thomas, Kusidani Satiki Ganguly, and Padurang Chowdhury, are going to look at spatial temporal variability in precipitation and extremes in India. Please go ahead.
Extreme events in India.
Extreme events in India, yes.
Okay. Thank you everybody for having this discussion. And yeah, as mentioned earlier, we're trying to understand how extreme weather events in India and assess spatio-temporal precipitation variability and extreme events in India. So just to give you a brief introduction of how it is, India is an extremely diverse country, both geographically as well as across its climate variations. And a lot of its dependency lies on rainfall in terms of agriculture. And impact of extreme precipitation can lead to socioeconomic losses, as well as losses to death and agricultural land and more so. So we wanted to understand in depth what are the kind of extremes that have happened over a period of time across regions. So our research questions, we had a couple of them. The first one was, what are the characteristics of extreme precipitation events in different regions of India, and how do they evolve over time with respect to the topography of various areas? And how does the observed data set, in this case, it's the IMD or Indian Meteorological Department data, compare with CHIRPS and iMerge data in terms of long-term precipitation variability? So I'll let my colleague Dr. Chaudhary here take on from methodology and explain further.
Thank you, Sataki. Good evening to all. Here I'm presenting the methodology of our study. So methodology involves several key steps, including identification of extreme events, temporal analysis, regional analysis, and comparison of various data sets like CHIPS, IMD, and iMerge. So I am going to give the explanation of one by one step. This is identification of extreme events. So that to identify the extreme events over entire India, we have we were downloaded the IMD dataset, that is point-based or grid-based dataset, and that was spanning with the longer period, that is 1991 to 2022. And for the pre-processing, we have done that data cleaning, quality control checks, and address the missing data. So we pre-process this entire data to ensure the reliability. And for this temporal analysis, we use this Mann-Kendall trend analysis for assessing the trends in extreme precipitation. As we know that Mann-Kendall is a very widely used in various fields or in various subjects to identify the trends of the data. And next is that regional analysis. For regional analysis, we divided the India into four different parts based on the climate, temperature, rainfall, and topography. So we have taken this four divisions as that IMD has already done. That is Indian Meteorological Department. They have already done these divisions. And next, that is based on this three data set, that is CHIPS, IMD, and iMerge data set. We have assessed the active and break spells for the 20 years period. I mean to say that for 2000 to 2020, this 20-year period, we have assessed the active and break spells. Next. So these are these three data sets and the characteristics of each and every data set. That is this CHIPS data set based on the satellite measurement, and that is calibrated and validated using this ground data set. And this data set extent is 50° north and 50° south, and India fits between this this extension, and available from 1981 to 2020, and spatial resolution is 0.05, that is near about 5 kilometer by 5 kilometer. And this is IMD data set, that our country's data set, which we are using for various purposes. That is available from 1901 to 2023. On this data set, we have done this extreme precipitation analysis. And the spatial resolution of this IMD data set is 25 kilometer by 25 kilometer, that is 0.25 degree by 0.25 degree. And this is another one, this data set, that is IMERGE, that is tropical rainfall measurement mission, adjusted and merged micro infrared precipitation rate. So that spatial coverage is 18° to 50 and 18 to 50. So temporal coverage is 1998 to 2020. So if you see here, the three data sets don't have that similar time step. That is, IMD is available from 1901 to 2023, and this CHIPS is available from 1981, and IMERGE is available from 1998. So that's why we have taken the last 20 years, that is available in three data sets for the active and dry spell assessment. Next, please. And you can see here that is based on this, using this man-control test, we have assessed the trend of this IMD data set, and we found this positive trend. And these are the four different geographical regions. That is Northwest India, this is Northeast India, this is central part of India, and this is South India. So we can see that the test is positive, and man-control test is positive, and we found that increasing trend. So next. This is the result of temporal analysis, that man-control test, trend test analysis is positive, which shows the monotonic trend, which tells us there is a positive trend, which indicates that is a increasing rainfall trend. So it positive trend value, it gives the 0.03, and highly significant p value, that is 0, which falls in the ejection region. It means that null hypothesis rejected, alternative hypothesis accepted. It means that it shows that confirming significant increasing trend in the extreme precipitation events. For next slide, I hand over to this presentation to my colleague, Steffi Thomas, please. Thank you.
Thank you, sir, for the opportunity. So I'll start from where Dr. Chaudhary left. So this is the spatial analysis result. As you might have seen in the figure above, the plots above, India is divided into 4 homogeneous regions. The division is already done by IMD based on the topography, the amount of rainfall, and climate patterns. Since India is a very large country, all these things are different for different regions. And so the Menkander test was performed for 4 regions, and the result showed that every region of India showed a positive trend in extreme rainfall. So the extreme rainfall is calculated. We took the 99th percentile of daily rainfall and identified the extreme rainfall events, and we performed the Menkander test for the 99th percentile data. And that's how we arrived at the positive trend. Next slide, please. These are the regions as given by the IMD. It's Northwest India, Northeastern India, Central India, and the Southern Peninsular India. Next slide, please. Okay, as the result shows, each of the regions showed a positive trend, but what we are more interested is each region showed different positive trends, and the extreme events show a more increasing trend in the Northwest India and Northeast India compared to the Southern Peninsular India. And we haven't got the time to look into the dynamics or the reasons behind this, but mostly we can say from the literature review that the coastline of India and the Himalayas at the top of India and different topographies are maybe the reasons why we have different kind of trend. Next slide, please. Okay, so as Dr. Chaudhary said, we also looked into the active and break spells of monsoon in order to get an idea about the intra-seasonal activity of Indian summer monsoon. So as Rajivan et al. Has identified break spells and active spells in Indian summer monsoon. So active spell is where Active spell is where we have a rainfall which is exceeding the value of 1 for consecutive 3 days, and break spell is where we have no rainfall, literally no rainfall for consecutive 3 days. So next slide, please. We have identified there are 24 active spells from IMD, or the IMD dataset have captured 24 active spells and 20 break spells. CHIPS data have captured 30 active spells and 26 break spells. IMUG data have captured 44 active and 56 break spells. So this may be because the resolution, as Dr. Javeri said, it's different, and but that does not matter for us because we took the domain average and calculated the active and break spells. So coming to conclusion, we have an overall positive or increasing trend for extreme events or gradual increase in extreme precipitation all over India from 1901 to 2022. And this positive trend can be attributed to the influence of global climate change. And spatial analysis also stated that we have extreme rainfall trends. And we can clearly say that these insights are really useful for facilitating well-informed decision-making by the policymakers. Moving on to next slide, Satiki will be continuing.
Yes, so in continuation with what my colleagues have said, due to the trends that we already see, it will be good to invest in early warning systems, which can help in risk mitigation, infrastructural development, and community management policies that can withstand extreme events, and further research and development for exploring specific impacts of extreme precipitation in different sectors. Yeah, future scope is if we can align the spatial resolution of IMD, CHIRPS, and IMUG datasets for improved comparability and accuracy, and investigate factors driving spatial variations and extreme precipitation across India, including geographical features, as well as identify key drivers to inform targeted adaptation strategies. Thank you, everybody. That's all from our group today.
Thank you so much. I think it was Typhoon Blues or something, right? The group? Monsoon Blues. Close enough. Thank you. Yeah, no, it was very nice. Thanks for the presentation. Are there any questions? Anybody has any questions? I have one.
Okay.
Yeah, so I start. So I wasn't entirely sure that I understood how you defined extreme precipitation. What exactly was the definition for the values? Was that a specific threshold or just the highest precipitation on that day, measured on that day, or in a month, or how was that done?
Hi, ma'am. So it was, we calculated the 99th percentile of the daily precipitation data.
Okay.
So that's how we identified the extremes. Yeah.
And then that was based on the whole period that you looked at?
Yeah, from
Okay.
1901 to 2020.
Yeah, okay. And then the next question that I had before I give over to Abigail. So you first showed the different regions where you had like all the different grid cells, and they showed all that trend exactly. But this is so the trend was calculated here for all individual grid cells, and then later you combined it to one trend for a specific region. Is that correct?
Can you repeat it?
Okay, so but what we see here is a trend for a specific grid cell, like
yes.
the 0 point, yeah. And so,
yes.
But later you showed for a trend in extreme precipitation for the whole region that you show, like northwestern India. And so you just combined the trends that you calculate here to get that overall trend. Is that correct?
Yeah, that's correct.
Okay,
yeah, that's
okay, just for a clarification. Thank you.
Okay.
Abigail.
Yeah, I just want to say this is a lot of impressive analysis considering, where you started and you were just looking at, plotting temperatures and stuff like that regionally. I was wondering about the spills and breaks. I don't know if those were the terms you used, but
yeah. No, it is active and break.
Could you explain a little bit what you mean by that and how?
Yeah, okay. So Indian summer monsoon as a whole is a process. Okay, so that's a season we have from June to September. Okay, so within the Indian summer monsoon, we have days where we have extreme rainfalls or just rainfalls consecutively, and there are breaks happening, which means consecutively for 3 days we don't get any rain. Those period is called break monsoon, and if we have continuous rain, it's called active. So within that particular season, we have active and break spells.
Very nice. Have you thought of doing kind of a similar analysis for drought seasons, which might kind of have the flip break?
Yeah, that's a good idea, but as of now, we just concentrated on precipitation.
Okay, congrats. This is a lot of work.
Thank you.
Thanks, Abigail. Robert.
You're not audible.
Sorry, I had two questions. One of them was how you think of like why you're looking at active and break in the context of looking at trends. I didn't understand what the connection between those two questions was.
Okay, so active and break are like phenomena in Indian summer monsoon. So basically, if we have prolonged break periods, that's not good for the agriculture here in India. So similarly, if we have prolonged active periods also, that can lead to flood and we might lose the agriculture, like produce and all. So the number of days or within a season, how much active and break spells we are having, that's really important for our like our country's agricultural sector. So that's why we are interested in the active and break spells. So why did we actually take 3 data sets is because originally active and break is done only using IMD data. So we needed to be, we needed more validation or like we wanted to see if some other data set is capturing this active and break monsoon periods. So this kind of work, like we don't have such kind of work here. We only use IMD data to calculate this. So just we wanted to see if other data sets also capture the same. So that's why we did it.
Okay. And then the other question I had is, you phrase this in terms of a trend. So the units, although you didn't write them out, but the trend is, a change in the frequency of extreme precipitation defined against the long term.
Yes.
With time.
Yeah.
So if you were trying to make a plan, what it tells you is that as time goes on, you'll see more extreme precipitation. And you're treating this whole time window of 120 years.
Yes.
As one, you're sort of drawing a line through one of them. And I wonder if you guys thought, if you were trying to plan for, you would say, well, I expect, based on these maps here, you would say, well, I expect there to be more extreme in most places, I expect there to be more extreme precipitation with time. So that's a useful piece of information, but there might be other relationships that would be maybe more useful. So one you could imagine, for example, would be with respect to temperature or, some other aspect, something about the large scale, because the little I understand about the monsoon is that it's a large scale phenomenon.
Yeah.
And so I wondered if you guys had considered that. I mean, it's of course more complicated analysis, but I wondered if you had thought about what other predictions you might make other than increase with time.
Sure, we have considered, but like, the time constraints and the amount of work we had to put into it. So like our future work might include even the correlation between these extreme precipitation events and some large scale phenomena like El Nino or something, or even the temperature change, or we can even consider the sea surface temperature or ocean heat content or something. Like we can make correlations and make more useful or more effective predictions, I suppose. But as of now, like with the constraints we had, this is what we could.
Thank you so much. Yeah, that's great. I have like one very quick question before we move on to the last presentation. So you look at the IMD data set. How many
Yeah.
stations are in there? Do you have an idea how many stations are covered in there?
Like within a so within a single state, we have hundreds of stations. It's the rain gauge data. So
Mhm.
we have like within a district or a state itself, we might have hundreds of rain gauges.
So the
Yeah,
data
I
is
don't-
already already condensed in the gridded form when you
Yeah,
plot.
yes.
May I add something in
Yeah,
this?
sure, sir.
Actually, earlier we have the data from 1901. So from that year, no, there are some stations were there, but after that we have installed that each and every district and talukas in county that stations. But now the more than 4,000-5,000 stations are there, and based on this observation data, they have converted the data into grid file format. So 0.50 degree and 0.25 degree, these two format, the data is available on the internet.
Yeah. Is that publicly available? Just
Yeah.
asking.
Yeah.
Okay, that's great. Yeah, no, because
Yeah.
we're always looking for data that we can use where there's, for evaluation and purposes. And so this is great to hear. I made notes about different.
Yeah,
data sets.
everything, that temperature, precipitation, the both variables data set is available.
Okay, perfect. Thank you so much.